Hey everyone, welcome to lesson number 1. Welcome to First Break AI. If you are really looking to break into AI, this lesson is where things get really interesting. Lesson number 1 is Hugging Face Beyond Upload. This is the lesson where we will break down the entire ecosystem for you. We will run Qwen3, which is a small 600 million parameter model locally. We will think of open models as supply chain. And not only that, we will also look at an actual model. We'll try to visualize how a model looks like. What is it required to run that model? What does it take to build a hub like Hugging Face? What to do if you have large data sets, how to look at those large data sets, how to analyze them. We will look at GitHub. We will look at Markdown as a bonus. We will look at how Markdown is used in almost all modern coding tools. How it is supported in GitHub, how it is supported in Hugging Face and Discord. We will also look at the 3 intuitions which drive this cohort, which are very important right at the start. We will also look at what are the files when a model is uploaded to Hugging Face, what are the various files that are there, right? So we have quite a lot to break down. This will be a longer video, and I hope that you get to enjoy, learn, and build along this journey, right? So let's start our video with where we are at this point. So we are at First Break AI. First Break AI is a cohort which is open. And our goal in this cohort is to build and learn at the same time. So there'll be this is a guided journey for you from commit to capstone, right? This is a free and open cohort which allows you to upskill in training, inference, and AI product building. Cohort has started. If you have not joined, or if you have joined just now, this cohort is open. You can drop in at any time and start looking at the material and start building, right? The first cohort is for 2 months, from 1st May 2026 till 30th June 2026. Even beyond this, these lessons are open and you can choose when and how you want to cover this, right? So we'll move to the first lesson. In order to reach the first lesson, you can either go to the lessons link and view the lessons from there, or we have a ticker here. Let's click on that. Actually, let me show you lessons. So this is the first lesson, and we have our introduction, and this lesson 0 is our introduction, and we are at lesson 1, which is Hugging Face Beyond Upload. Right. So yeah. So as I mentioned, you must have covered lesson 0. Welcome to First Break AI, which basically deals with or enables you to build a blog using any AI coding tool. So you build a blog, preferably Quarto blog, using any AI IDE, be it Cursor, be it Claude Code, or Codex, whatever is your choice, right? Now let's look at the lesson itself. Before we begin, let's think of, let me zoom this a bit. Yeah. Let's think of a thought experiment. Let's build a thought experiment. Imagine for a moment that something like Hugging Face doesn't exist, right? By the way, Hugging Face is the is the GitHub for AI models, right? So let's imagine something like this doesn't exist. There is no pip install transformers. There isn't any place where you can upload models, view data sets and all, right? Imagine you are only given one file, which is the one file or set of files, which are the actual model files. And you are asked to build something like ChatGPT, Claude Chat, basically build an app where you ask a question and you get a reply. So you are expected to deploy that AI model. What would it take to deploy that model, right? If transformers does not exist, if Hugging Face does not exist, right? So to answer this question, first we will have to, what we'll do is we'll build parallel worlds. In one world where Hugging Face exists, what are the moving parts? What are the critical areas within Hugging Face? For example, we'll look at Z storage, we will look at transformers library, we'll look at datasets library, config.json, we'll look at tensor files, other things. And the second world, we will try and mirror this, So we'll try and run a model in pure C and try and map if transformers does not exist, what do we have to do to run that file in pure C, right? So let's look at the three intuitions first. What are the three intuitions? Right. So the first intuition is that modern language models, which is modern LLMs, are a stack of repeated blocks, right? So you look at Qwen3 and you look at input, text embedding, then decoder layer, RMS LOM, linear, and then output, right? And this can be expanded. So if I'm to go to this site, which is a site which helps you visualize models interactively, it's called HF Viewer, and it allows you to move the granularity. So the granularity at this moment is at the lowest level. We move it up a bit and we can see more details within the model. We move it up a bit and we can see even more details, right? But at this point, we do not care about all these layers. We care about input, we care about output, and something happens in between for this lesson. So this is what model looks like. The first intuition is, whenever you imagine a model, think of this stack. Yes. So think of this stack. That is the first. The second intuition is that LLMs generate one token at a time. So if you look at something like this, so you can see it is generating one token at a time. The input text, the question that is asked here is, write a sonnet about love. So write a poem about love, and LLM starts writing a poem, but it's one token at a time, right? So that's the second intuition. Third intuition is that the LLM, and this is a critical intuition, which is something that a lot of people get wrong. So first of all, models have a vocabulary. Like if I am speaking English, I have a set of vocabulary, set of words, which I can use to construct sentences. Similarly, Qwen3 has a vocabulary of around 151,936 tokens. So let's assume 150K tokens. When you ask a question, what is the capital of India? The answer is Delhi. But LLM does not just spit out Delhi. It will spit out probability for all the tokens, all 150K tokens in its vocabulary. We are simply sampling, which means we are simply picking the one that we want, which is in this case would be the one with the highest probability. So Mumbai, Bangalore, Washington could be lower probability, and Delhi has a probability of 0.71. So we have picked the top three, and out of top three, we are displaying the top token, which is Delhi. That's how models work and think, and that's why we need decoding strategies, which is mentioned in this very nice blog by Hugging Face. decoding strategies in large language models, around 2024 article. Okay, so we'll go back to our session, to our lesson actually. Yep. So once we have understood the three intuitions, repeating them, model is a stack of repeated blocks, LLMs are autoregressive, they spit out one token at a time, and number three, the model outputs a probability distribution over the entire vocab. Yeah. So the same thing is mentioned in this office hours as well. I think I've moved to this office hours instead of the lesson. Let me go back to the lesson. Go to lesson 1. Hide this transcript. Yeah, we're good to go. Right. Now we will think about which is our model that we want to target, right? We will target Qwen3-0.6B. Why are we targeting such a small model, 600 million parameter model? There are bigger models. You must be aware of frontier models. You must be using them daily, which is Claude Sonnet or Opus or GPT 5.5 or any other model that you're using. Even open source models like Qwen3 Coder, DeepSeek V3, V4, Minimax, GLM. I used an 8GB model quite a lot, which was called Microsoft model, which was called Phi4 multi-modal instruct, right? But we are not going to use that. We are going to study Qwen3.6B. Well, always we have this temptation that we assume these models to be uninteresting toy projects, right? But we must not forget that they are architecturally similar to these bigger models, and they offer us a good way to learn about LLM inferencing and training. In fact, for most of the experiments, we'll be using a smaller GPT-2 model, right? So that GPT-2 model and Qwen3 is what we'll be using. Qwen3.6B has a newer cousin, which is called 3.5, 0.8B. This is a multimodal model. So these three are ones which we'll basically look at, right? Remember that this model is 600 million parameter. Most of the models that you work with are at least 200 times the size of this model or even more. This Qwen 3.5 has had more than 2.8 million downloads in a single month as per Hugging Face UI, right? Now let's move to Hugging Face. Hugging Face is the GitHub of models, and this is a good comparison, right? Now we will start thinking of models. We saw the architecture of Qwen3.6B earlier over here, right? So we saw this. Now let's see how this model actually looks like on Hugging Face. When LLM teams upload these models onto Hugging Face or some other hub, how do they look like? That's our main focus right now. And Hugging Face, as I said, is the GitHub for models, right? If you understand if you understand GitHub, you will sort of appreciate Hugging Face as well, right? It uses Git underneath. So as you know, both GitHub and Hugging Face use Git underneath. Git is an open source tool, right? So similar to GitHub, this Hugging Face also sort of has commits, branches, pull requests, and issues, right? Now the model card that you see it has a README.md just like GitHub. .md stands for Markdown. It is used extensively in GitHub. It is used extensively in Hugging Face and in Discord, right? So let's look at what is a Markdown file and why is README.md so special, right? So if you look at any repo, so let's look at this repo. And if you create an issue, a new issue, so we are creating a new issue. Let's click on new issue. We can actually, it's a new issue, right? And so let's put in heading here that first issue for my code. So when you preview this, you can instantly write code naturally using special symbols, and it will be rendered very beautifully. So you can write headings, you can write first subheading, right? And it gets rendered very nicely. So you can do all the formatting, you can write whatever you want in plain text, it gets rendered nicely. A list can get rendered, task list can get rendered, code blocks can be created, right? And these code blocks are nice because instead of a messy sort of setup, you have a copyable code block over here, right? So to do a little bit more deep dive into this, we have got Dillinger.io. This is a website where the author is basically showing us the full extent of Markdown. So not only can you write headings, subheadings via text formatting, you can write lists, and lists are formatted in this manner. As we showed, we can write task lists, you can write links and images. You can write block quotes. You can see block quotes look really nice. In fact, let's try block quotes. It looks really pretty. This is the block quote. We go to so we'll write it at the bottom. Kind of duplicate. We'll remove this. Let's preview. Yeah, so you can see there's a nice vertical line which separates, very, very pleasing, very good aesthetics, right? So you can write block quotes as well. So this is a good sort of a first look, and it can render math equations very easily. So you have got sort of MathJax like formatting which allows you to view. So let's try this as well. Yeah, you can see just rendered the inline math very well, very, very cleanly. This is what we want. So Markdown, very, very helpful, right? And what is the purpose of README.md? In GitHub, if you have a Markdown, if you have a README.md file, Markdown file, it's going to get rendered on UI immediately, on GitHub UI. So on this route, I have a README.md, it's going to get rendered here. In lesson 1, I have got 2 Markdown files. I can read this Markdown file as well by clicking on it, no problem. But the readme.md is going to get rendered by default. And so you can keep on writing Markdown files, very good for write. Quarto uses Markdown file by default. So you can just write things regularly, format them, and build really good blogs and content with ease. So, and a side note on Markdown, which is given here. Markdown is the lingua franca, or the language of choice of AI-assisted work. And this is like a small, unglamorous skill. I don't think it's unglamorous, but it has a big payback. It helps you a lot, right? So every model card is Markdown, every issue is Markdown. Discord messages are like in Markdown. You have Cursor Claude, which reads Markdown files very, very nicely, planning files and everything. In fact, there is a post by Andrei Karpathy where he talks about building a personal LLM knowledge base. And he's basically suggesting that let AI tools sort of index and work out how your knowledge exists on your laptop or on Obsidian or wherever. You have a bunch of Markdown files. Let LLM build a personal knowledge base out of that. Let it connect things and understand how do you think about the world, So basically it will be a personal LLM knowledge base, and this tweet went viral. So even there, Markdown was the cornerstone of his tweet. Right? We spoke about GitHub.md. Sorry, README.md. Right? So this part is covered. Now we will look at something. We'll go back to this part. So first is, why does Hugging Face exist? And why not use GitHub, right? Because Hugging Face is trying to solve different problems. There are engineering constraints. Like the biggest constraint is there with GitHub is that it won't allow a file which is more than 100 MB. There is a hard limit that GitHub puts on every file. I think it's 100 MB and it has not changed. You can commit those files, but when you try and push it to GitHub, it will get rejected outrightly. GitHub has solved this problem. It's not that this problem has not been solved. So there is something called as Git LFS, which allows you to store large files, specifically blobs, large blobs. And LLM models are like large blobs, right? So you can have a separate storage for them. And you only leave a small pointer to the repository. So you have normal files, your Python files, your React files, your TypeScript files, any other file that you have just gets uploaded, gets committed and pushed normally. There are pointers to these large files and your single repo then works really well. So GitHub was using LFS, Hugging Face was using LFS, and they have transitioned to another package called Zet in 2025. So let's look at any model, right? Now let's first figure out how to locate a model. So one of the best ways is if you know the model. So like I know Qwen3-0.6B and it will display under models and I can look at it. The other way, if I do not know the model name, I can go through the organization and collections. So Qwen has published a lot of models. So it has around 33 collections. We click on collections, we go down. There is Qwen 3.6, 3.5, but we want Qwen 3. Here is Qwen 3, we click on it, and somewhere 4. Yeah, so this is Qwen 3.6B. As I mentioned, readme.md is always, the model card is readme.md and it is shown here. So the readme.md file is sort of rendered or displayed here. Now we look at files and versions. We click on files and version, and these are the bunch of files that are there. The license, there is readme.md, there is config.json, then there is this model file, safetensors. I want you to look at wherever there is Z written, and specifically for large files, those are blobs. So this is the actual Qwen3.6B file, model.safetensor. Remaining files have their own purposes and they are needed to run this model, right? This is what is mentioned here. We have got, if you open the repository of Qwen3.6B, you will, if you click on files and versions, you will see these bunch of files. Readme.md, we have discussed. Config.json is the critical file which we will discuss here. Apart from that, we will only discuss model.safetensor. .safetensor, .gguf, .bin are the weights themselves. Right. Let's look at config.json file. It is the blueprint and then transformer is the builder. So you can think of it like that. We will look at architecture. We will look at hidden size. For now, we will look at vocab size. That's all that we care about. Right? Yeah. So the same thing is visible on the model card. This is not the model card. Yeah. So let's click on config.json. There is the architecture. Then somewhere below, right at the bottom, vocab underscore size is 151936. For our purposes, we will say that the vocab size is 150K for the discussion in this lesson. Right. What we'll do is we'll copy this, right? And we will go to Google, we'll type transformer and paste this blindly. I just have to put a Q in front. Yeah, paste this blindly. Now we see a Qwen3 for causal LM. This is the class for Qwen3.0.6B. You will be able to see the actual file, the actual code in Transformers. Transformers is a library supported by Hugging Face. So you can click on this and you're going to see the actual code, right? On the right hand side, I think you can see classes as well. This is a relatively new UI by GitHub. I think maybe a year or a couple of years back they started this. So you can click on this and you can see this file. So this is the model file. No worries. Yeah. This is the class, right? So in it we have forward, right? And okay. Now let's look at the documentation as well. So we will go back to Google and write transformers and doc, and documentation is in the top left. So again, you can write Qwen3 for causal, just copy paste the class, and you are going to get this transformers dot Qwen3 for causal, right? You'll see all the parameters here and one example as well, and other classes are visible here as well. Right. So we are back at our model card, right? So as we said, we are going to focus on hidden size, but mostly we are going to focus on vocab, so which is 150K. Architecture for this model is Qwen3 for causal LM. Config.json, what it contains I've already mentioned. These are all fields from there. For 3.5, you will see that the class is Qwen3 5 for conditional generation, right? So why does this class even exist? Because the weight is a bag of numbers, bag of tensors, and we want these tensors to, we have to multiply, and these tensors have to work together, right? There's multiplication, there are other operations involved, and then everything gets wired into a forward pass. So in order for these operations, you need to create these classes and work with them. So right now, transformer library is doing the heavyweight with all these causal LM classes, and we will have to work and build our own class in C to mirror this. As I said, there will be two worlds, one where transformer exists and one where transformer is not there, and we need to build our own class. So we have seen Hugging Face documentation page as well, right? This part we have already covered. Do we need math for this particular course? The question has come up early and is an important question. The answer is no. We will go the reverse way. We will first build and we'll look at math, for example, in rope, in attention, wherever math is required, we'll look at that, right? The heart of this lesson, which we will be picking up in the second part, there'll be another video lesson, lesson 1B. We'll be running Qwen3 in pure C, right? And as we said, this is part 2, second world where Qwen does not exist. We will mirror what transformer and Qwen3 for causal LM has done in C itself. To do that, I have created a repo. So here is it. And this repository contains like a sub repo in it, and you have to click. So this is the repository, and in this there is this run.c file. So what we'll do is this is a core file. We have over here, if we look at, let me open this repo in cursor. Yeah, so what we'll be doing is run.c, we'll be creating a binary, and that binary is going to, we'll execute that binary. So if you look at this repo, this wasn't completely unnecessary because it's already open. So here it is. I have to switch. Yeah. So this is the repo. And this is the run.c file. Now, this has all the code that is required to run the model itself, right? And you can see that this is the actual file or actual model that is there. So we are going to basically do something like this. We'll run using the ggwave file, and we have a system, we have all these flags as well, right? So with this, we'll be running that model file on your local, just like you chat with ChatGPT or with Claude Chat, right? You will get similar prompt, and you can ask a question, maybe what is the capital of US, or why is attention required, which is the best, how do you work with AI agents, whatever you want to ask, right? So, and you can even set flags like thinking on, multi-turn on, and we'll see that. The advantage of working with this is that we are going to basically understand everything, like what is temperature, how does it impact your output. We'll look at different flags within the model. We'll look at thinking on and off, right? And this is a table which basically compares the two worlds. If you have Python, you basically are using NN module a lot, and here you are doing the same thing using transformer weight. So you have to create this. Similarly, for attention, you have to build from scratch. So all the heavy lifting that was being done by transformers, you'll have to do that. So this repo is basically a fork of the original repo, comes from William Song's repo. So just I'll click on this. Yeah, this is the original repo by William Song. It's called Qwen3-0.6B. It's a fork of that. You can view that repo as well. Okay, so this part basically focuses on these areas. In the next segment of this video lesson itself, we'll look at datasets. So I'll take a small pause here, and then we'll move on to the next session. Okay, let's start with the part 2 of this lesson, which is datasets. Datasets is also a very powerful offering by Hugging Face. There are 3 ways to look at datasets. Three ways in which we can interact with datasets, do some analysis on the datasets before we move on to our main task, right, of actually downloading the dataset or using them. So there are three ways to go about it. So what we're going to do is we are going to look at a few. First, let's see which datasets we're going to look at. So the primary dataset that we're going to look at is FineWeb. And FineWeb, there is a smaller version of FineWeb, which will be used in experiments quite a lot. And for this lesson, let's look at this 15K datasets called Databricks Dolly 15K. It's an instruction tuning, beginner friendly dataset. And what will we analyze in this? We look at the dataset and try and see what are the columns that are there. And what are the various unique values in certain columns, specifically columns like category, and what is the length of certain fields, critical fields in that, right? So we want to understand the distribution, how big is the output. So looking at this particular data set, first let's look at FineWeb, which is a very big data set. You can see that this has got almost 54.8 TB. And I think it has around 18 trillion tokens. Let's go below. I think we mentioned everything here. Yeah. So they had 15 trillion tokens, and now this new dataset has 18.5 trillion tokens. You can see various slices or subset of this dataset here. This is the common crawl dataset, and it's very clean dataset. It's deduplicated. I think most LLMs use this dataset itself. Probably they have even a better deduplicated and cleaner data pipeline with them ready, right? So, for example, you can look at the latest one, 2025, 2026 here, and this is the data set. Sorry, this is the data set. And important point here, you can click on any of them and see the prompt, see other things that make sense to you. I'll just move this entire window so it'll be easier. So this is the data set. We'll go back, and there are three ways to look at this data set. The first way is that you can basically this is FineWeb. So let me just open here FineWeb again. Here one is the dataset viewer that you can see in front of you. So this is the dataset card. Again, there are files and versions here, but this UI enables you to look at dataset and go to Data Studio. For this, it's not available. So what we'll do is we'll go back to so we can go to Data Studio and we can further search the dataset, and even there is an console here as well, right? So for example, you can see all these data sets here, and you can even use agent to work with these data sets. So you can use agents to work with the data set, right? So for example, I have asked this agent to, so first of all, this particular Dolly 15K has instruction, context, response, and token count. So there is an instruction like name some famous rock band from 60s, and then there is an answer to that. So what we are trying to figure out is under the category, right? If you look at the original one, this is under category. What are the unique categories? So we have listed 1, 2, 3, 4, 5, 6, 7, 8 categories. There are these 8 unique categories in this 15K dataset. And what are the count under these? So OpenQA has 3,700, brainstorming has 1,766, creative writing has 709, right? And you can even write complex queries from here itself. So this is a community query, which is very interesting. I think this is the one. Yeah. So basically this will list out all the records, all the rows which are under 25 to 75 percentile of the token count. So if you run this query, you're going to get something like this. So these token counts are going to be not too high, not too less, between 25 and 75 percentile. So not too responses which are not too small, responses which are not too large. This is one of the ways to look at it. The other one is called Croissant endpoint / Croissant. And if you look at, this is the endpoint. It's going to, if you hit, like this is the curl command, curl, give the dataset / Croissant, you will get dataset, you will get JSON LD, or you will get metadata format in that, right? So this is also useful, specifically when there are very large data sets, large number of columns, and some meta information that you need. So I have already done the curl command and using this particular JSON LD playground, trying to visualize this file. So you can see that this is for FineWeb. So it is giving you URL, it is giving you other key columns like ID, URL, what else is there? Token count is there. What else is there? Text, date, language score. Yeah. So all of this is mentioned over here. So this is basically following some standard metadata formats, which is from schema.org, and parakeet and JSON LD formats are used frequently within Hugging Face. So you get information through this manner. Number one is data. So there are 3 ways. Number one is data viewer, which is the UI given by Data Studio, which is UI given by Hugging Face themselves. Number 2 is parakeet. Number 3 is like the most interesting one, right? So number 3 is here. This is the most interesting. This is using something called as datasets and load underscore datasets. So we'll be doing a lot of data analysis here, and this is the file through which we'll be doing the data analysis. Now, just to let you know, this is a notebook, and notebooks are basically environments where you do not have to, they work really well. They have a kernel environment and they work right out of the box. Very good for learning. And via Colab, you can basically connect Colab. Basically, if you open this in Colab, you get access to GPUs directly. So you can run this for free in Colab, and it's pretty useful. So one of the checkpoints was to, one of the checklist was to have to set up a Colab account. And once you have a Colab account, all you need to do is you need to go to your Colab and then go to file, go to open notebook, go to GitHub, and this particular file is hosted on one repo, which is First Break AI code. And you go to this repo and you copy this, and then you just paste it here, hit enter, and it will list down all the notebooks that are there. This is already listing this, right? You can select this and it will open. And then you can click on connect, which is here, connect, and set your runtime. In this case, we don't need to change runtime to a GPU, and this will start working. Okay. So this is the thing with this file. I'll zoom it a bit for now. Right. So we are at lesson 1 and we are basically trying to do data loading and initial inspection. So we are going to use datasets, pandas, and Matplotlib in this particular file. Datasets is again a library provided by Hugging Face. We are going to use load underscore dataset. We're going to use load underscore dataset, pandas as PD. Right. So first we just capture the dataset name and pass it to load dataset along with split that we want. And then we pass it to pandas. And we can print the shape and like first few rows from this. So the shape is obviously, as the data set is instead of a messy sort of setup, you have a copyable. Okay. As I was saying that the shape is, has around 15K records, right? So the shape is there, 15011. These are the first few records, right? So now what we're going to do is this is just a duplication. We'll do some initial inspection. We want to, for example, know if there are any NaN records in this data set, which is 0. We want to know the columns that are there. There are 4 columns, which we saw in the shape earlier as well: instruction, context, response, and categories, right? We want to know what are the categories and what is the count, which is the same thing we did via Data Studio via SQL queries earlier, right? So it's the same count and everything is here, right? Now we want to know the length distribution. For example, we want to know for these 3 columns, what is the count? Here the count. What is the mean? And list. So again, same records here as well, right? And then we'll plot something very interesting. We'll plot the response length distribution. So one field, which is a response, we want to see, for example, response is here. And what is the 25th percentile? What is the 75th percentile? And we want to see, is there a max here? There is like 2000. It says 2000, right? So you can see there are few records that are at 2000. The 75 and 25 percentile is between 78 and 430, right? So we know most of the records are have token count of 78 and 430. So we understand what is the mean response, what is the size of the response. So for example, if you are expecting very, very large, is this 26,000? Something is wrong. If you are expecting very, very large token sizes, so this data set then would not be right for you. So you can check right now using this and this plot, both these analysis, if this data set is sound for you. You can do various checks like these. You'll have to do it because you have to train models, you have to fine tune. So you have to basically test the data set for that. Now you can look at few short examples and you can look at few larger examples, right? So as the record number 1867, what is console war in video game? Apparently that summarization is the biggest with 26,000 characters. So everything is matching here, right? We see this maximum and somewhere above, this is the record, the maximum record. So we have actually located the maximum record also. Let's see if we can locate the smallest one, which is what? 1. Okay. So 1, I think there would be a lot of records with 1. Very long, very small. Yeah, so there is like one word answer, Perseus, and we have small answers, right? So that's also true. So we have like the top 10 biggest responses. So you can basically guess, you can have top 10, you can even count, beyond number. Like if you want to see what part of this data set has more than 1000. From here, you can see the count is going to be very, very small, right? Like this, between 500 to 1000 tokens, you have around 2000. So this count is pretty low. Like, with more than 2000, you have barely any tokens. I can even plot a more granular graph and you will see that. So this, just in one view, you come to know a lot about the data set. That's how you analyze data sets. Very, very critical skill in the field of AI, inferencing, in learning, even agentic AI. This is very, very important, right? So this concludes this lesson. We'll have a second part to this lesson where we look at Qwen3, running it locally, looking at the code, also looking at Transformers library deep dive. I hope this was useful for you. Again, welcome to First Break AI. I hope you have a good time building things with us. Happy learning. See you and goodbye.